Good day, ladies and gents. We are on day 3 of our EOC review. All right, so let's go ahead and get started. Number 1, quadrilateral ABCD is graphed on the set of axes right here. When ABC is rotated 90 degrees counterclockwise, so that means you're going against the clock. So we're going this way, counterclockwise. So we're going to be turning this way around the origin. Its image, where does it land? Okay, so we're going 90 degrees this way. So put your pen in the center. And now we're going to, right here, we're going to turn this way. So this A is going to land over here. So we're going to turn this 90 degrees, boop, and this is up now. So if this is up, where are the coordinates? Where is A, B, C, and D? All right, A, if this is up, A would be at negative 1, 2, 3, 4, 5, 6. So negative 6, negative 2. B would be at 1, 2, 3. So negative 3, positive 1, 2, 3, 4. C is at positive 1, positive 2. And D is at negative 1, 2, negative 1, 2, 3, 4. All right, so with that idea right there. All right, so if we have that, so when we rotate, did it preserve all the size? So that is a definite yes. So when we turn this, all the sides stay the same. So did it preserve? Yes. So when we preserve, the only one that does not preserve is dilation. So dilation, that zooms in, zooms out. That does not preserve. Preserve. If I knew how to spell. Okay, so preserve. So dilation is the only one that doesn't preserve. The other ones do. So rotation does preserve. So that's good. So the answer is definitely a yes. So this is out and this is out. So it's between these two. Now, did A land at 6, 2? Nope. Did B land at negative 3, 4? Yes, it did. So the answer was D. And that's pretty simple, right? Cool, let's keep going. All right, number 2. So number 2, what coordinates coordinates of P if the image of point 3, negative 4 after we reflect over y equals x? All right, so what we can do here is two different things. Basically, we're saying that the y turned into x. So basically, we're just saying that these two switched. That's all it's saying right there. So if they just switched, it would turn into negative 4, 3, right? So that would be negative 4, 3. The answer would be D. Or you could graph this. So if you graph this, so we're starting at 3, negative 4, which is right here. Now we're reflecting over y equals x. So that is this line right here. You see I'm putting all these dots here just to keep that organized. All right, and I use my straight edge to connect the dots. All right, so we're reflecting over this line. So if we follow this, 1, 2, 3 and a half, there's a half. 1, 2, 3. That's one way to do it. I like going this way though, going along the lines. This is 1, 2, 3, 4, 5, 6, 7 until I hit one of those points. 1, 2, 3, 4, 5, 6, 7. I still landed in the same point. Awesome. All right, so where's that coordinate right there? So we reflect over that line. That was negative 4, positive 3. So both ways were totally correct. So we could either do it this way or we could do it graphically. So just like this. So those are two different ways how to do this. Boom, boom, boom. All right, cool. So just in case we wanted this, we were here, reflected over this line, and we landed right here. So that was another way how to do that. Awesome. Okay, next, number 3. Number 3 is we have this point right here, and we're doing 3, -4. So, and this is translate. So basically we had this point, -5, 2, and what we're going to do is we're going to add this 3, and we're going to subtract this 4. Where did we land? We landed at -2, -2, which was C. Now, if you didn't feel good about that one, you could do the graph way, which is right here. We're starting at -5, +2. So that's where we started, and they said to go +3. So 1, 2, 3, -4. 1, 2, 3, 4. And this is where we landed. And where's that coordinate? That is at -2, -2, which is exactly where we said we were. So you could do that way, or you could have done your graph where we went +3, -4, and we landed right here at -2, -2. So both ways are totally correct. All right, keep going. All right, number 4. So on number 4, they're saying in the diagram below, a square is graphed on the coordinate plane. A reflection over which lines does not carry the square onto itself. So let's see. X is 5. So here's the x-axis. On the x-axis, this is 1, 2, 3, 4, 5. So here's the x-axis, here's 5. Now how do you hit that? You hit it like this. If I reflect over that line, it would land over here, right? Okay, that's already not going to work. That one does not work. I already know that that's no good. All right, let's check these other ones. So that was x equals 5. And make sure you write that down so we can look at this later. All right, how about y is 2? Here's the y-axis, and here's the number 2. Now, how do you hit that? How do you hit that point? So here's the y-axis. How do you hit this point right here? You would smack it this way, right? All right, so if you smack it that way, that'd be y equals 2. So this point right here was 1, 2, 3. 1, 2, 3. See how it landed still on one of the other corners? This would fold over this way. So everything works. So that one works. How about y equals x? So that'd be 0, 0. And I just rise from left to right. All right, there we go. All right, that's y equals x. And you see how that just folds over onto itself? So that works. And then finally, this little doozy right here. All right, so that one right there. So if I just subtract x from both sides, that would be y equals -x plus 4. So the y-intercept is at 4. 1, 2, 3, 4. We go down 1 to the right 1, down 1 to the right 1. And you see this line right here? That's what it's making. Wish I could draw. Okay, so it makes that right there. All right, and that right there is y equals -x plus 4. All right, and that once again folds over onto itself, so that's good. So definitely A was the bad one, so that's our final answer. That's the one that sticks out. And number 5. All right, so number 5, we have this picture. Which one is not congruent? I don't even have to graph this. I know for a fact that translation is good. I know that rotation is good. I know reflection is good. All these are good so far. All these are good. The one thing that doesn't work is dilation. That one, that's where it blows up, right? That's where it gets bigger or smaller, depending on the situation. So this one, so it has a dilation of 2. Now, if it had a dilation of 1, you would say it exactly the same. But dilation is the one that's bad, so that was the answer. So that's the one where it's not congruent. So all these were good. This one was the bad one, right? And there you go. You don't even have to draw it. You just knew that's the one that doesn't work. And number 6. All right, so number 6. Okay, so this one's important. This, it's going to be rotating 180 degrees about this point. Okay, so this right here, that means we're going to do the undo. The undo, redo, that stuff. So we're going to make the chart. So our points are CAT. And your CAT, your points were 1, 3. So this is the original. 1, 3, 2, -1, and 4, -1. All right, so that's your original. All right, the first thing we're going to do is undo. So we have, we're going to go 180 degrees around 1, 2. So what's the undo of +1, +2? So we're going to subtract 1, we're going to subtract 2. So that's us undoing this point. So take all of these, and I'm going to put this in the calculator so you can see what's going on in my head, especially if you guys are in different languages. All right, so we're going to take all these x's, and we're going to subtract 1. So subtract 1, we get 0. 2 minus 1, we get 1. And 4 minus 1, and we got 3. All right, so we did all of these, and we subtracted 1. All right, now let's do all of the y's. 3 minus 2. -1 minus 2. And -1 minus 2. We got -3. All right, so now we're going to take this and we're going to graph it. So we're going to graph our undo. So take this, we're going to graph that. So take this point. We have 0, 1. That's my C. We have 1, 3. Sorry, 1, -3. That's my A. And we have 3, -3. That's my T. Okay, so now we're going to rotate this. So go 180 degrees. And they didn't say which way, so we go against the clock. So we're going to rotate to 180 degrees. Boop, boop. And where did we land? So if this is up, we're C, A, and T at this moment. C is at 0, -1. Your A is at -1, 3. And T is at -3, +3. All right, and we're going to take those coordinates and write them in here. So we were at 0, -1, -1, +3, and -3, +3. Fabulous. Okay, so now we're going to redo. So redo those coordinates. So our original coordinates were +1 and a +2. And these two should be opposites, so it's perfect. So we're going to take all these, we're going to add the 1s, all these, we're going to add the 2s. So I'm going to show you my calculator here. All right, so we have 0, we're going to add 1, -1, we're going to add 1, and -3, we're going to add 1. So take all these, we're going to add 1. And we got 1, 0, and -2. Now take all of the y's, and we're going to add 2. -1 plus 2, 3 plus 2, and 3 plus 2. We got 1, 5, and 5. And that right there is your final answer. So 1, 1, 0, 5, and -2, 5. Now this is just one way of how to do this. That's what works for my class. If you find another way how to do this, rock it out. All right. And I do believe we are done for the day. Have a great and wonderful day.